Okay, so hi guys, we're still on trapezoids. This is our 7th or 8th lesson in the second quarter, trapezoids and middle line theorems. Okay, so let's try to read this problem. ABCD and CDEF are two trapezoids such that sides AB, CD, and EF are all parallel and measure 12, 27, and 72 respectively. If ED is equal to 3 and points B, C, and F are collinear, and A, D, and E are also collinear, so what is the length of AD? First, we have to draw the problem. So we have here, they said here on the problem, so let's try to draw it here. So we have here one trapezoid, and we have here another bigger trapezoid for this one. There you go. So we have here AB. AB is parallel to CD. Now it says here that B, C, and F are collinear. So that means this is B, C, and F. Then this should be A, D, and E. Now we have a perfect figure for this one. According to this problem, let's try to draw an imaginary line here. According to this problem, AB is equal to 12. Okay, it also says here that CD is equal to 27. Now, if this is 12, this is going to be parallel. BD is going to be parallel to this line 7. Let's say that this is X and this is Y. Okay, so this is 12. Now, if this is 12, and CD is 27. This entire thing is 27. So that means CX must be 27 minus 12, which is around 15. So this should be 15. And then we have here, this is also 12, since they're all parallel to each other, forming a rectangle. And FY is going to be 72 minus 12. Since FE or EF is the measurement of this line, which is 72. So that's going to give us 72 minus 12, which is 60. So therefore FY is equal to 60. Okay, so what is the length of AD? So this is the line segment that we want to find for this given problem. So how can we solve for that side measurement? Okay, so for this problem, this is actually a similar polygons problem. More of a similar polygons or a proportionality problem. We will tackle this on our third quarter, but this is a bit advanced, especially on our second quarter. We're just discussing trapezoids. But if we're going to use the properties of trapezoids, as we have used here already, so we have one pair of parallel lines. So how can we find the measurement of AD for this problem? Okay, so since we know according to our given here that DE is equal to 3, okay, for this problem, and it says here that this is 3 and this is 12 and this is 12 and this is 12. So what proportion can we create in order to find the value of AD for this problem? Since we've already identified two trapezoids that are similar to each other, let's try to separate them. We have A, B, C, D, and then we have C, D, E, F. Let's try to write their side measurements. So this is 12, this is 27, and this is 27 again, and this is 72, and this is 3. drawn two similar trapezoids. Okay, so we can use these trapezoids later. We could also draw two similar triangles for this problem. Okay, so we have one small triangle that's similar to a larger triangle. Now, what are those two triangles? We have BCX, and we also have BFY. Now, according to this figure, CX is equal to 15. FY is equal to 60. Okay, and BX, we don't know the value of BX. But according to this part, XY should be equal to 3. Since XY is parallel to DE, and DE is equal, or ED is equal to 3. So therefore XY must also be equal to 3. So therefore from this figure that we have, if we can solve for the value of BX, we will be able to find the value of AD. Since BX is parallel to AD for this problem, if we've solved for BX, we're going to solve for AD, or we can solve for the value of AD. So for this one, we can write, okay, for this given problem. Okay, so we can write that Fy all over Cx. Okay, so that's going to be equal to By all over Bx. And since we know the value of Fy, so that's 60, and Cx is equal to 15, so that should be equal to the value of By, which is equal to Bx plus 3, and Bx is just Bx since we don't know the value. So this is going to give us 60 times Bx is equal to 15 times Bx plus 3, and that should give us 60 Bx is equal to 15 Bx plus 45. So therefore 60 Bx minus 15 Bx is equal to 45. So that should give us 45 Bx is equal to 45. And if we divide both sides by 45, what will be the value of Bx? So Bx, or Xb, is just going to be equal to 45 over 45, or just simply equal to 1. Now, since Bx, for this problem, is equal to 1, and Bx is equal to AD, so therefore AD must also be equal to 1. Okay. So therefore the answer for this problem, using similar triangles, and also trying to visualize them using trapezoids, trapezoids, the answer to this problem is just 1. The length of AD is just equal to 1 unit. And that's how we solve